wave-particle dualism means the particle can behave as a wave and a wave can behave as a particle. See, if you take a light photons, when you observe the photoelectric effect, actually the light photon is falling on the polished metal surface where the electrons are ejected, which proves the particle nature of both light and electron. And similarly, light undergoes diffraction, reflection, because it behaves as a wave. So electrons also, sometimes it behaves as a wave and sometimes they behave as a particle. So a scientist called de Broglie, he related the equations of Planck and Einstein's mass energy relation. So the Planck's equation and Einstein's mass energy relation are related like this. Nu is equal to C by lambda, because you should always remember this one equation. C is equal to nu lambda, which means that frequency multiplied by wavelength will give you the velocity of a wave. So C is equal to nu lambda. So nu is equal to C by lambda. So E becomes hc by lambda. From this you can take the lambda to the left side and E can be brought to the denominator. So lambda is equal to hc by E. So this E you can substitute mc square. So this C and this C can be cancelled. So what you are getting is lambda is equal to h by mc. C is velocity of light. Suppose if a particle is moving with a velocity much less than that of light, which is called mv. So lambda is equal to h by mv, which is equal to h by p. So which is the de Broglie matter wave equation. So lambda is equal to h by p. So lambda is inversely proportional to momentum. So when momentum increases, lambda decreases, which means the wave nature increases and the particle nature decreases. If momentum decreases, wave nature decreases. Therefore, lambda and momentum are inversely related, whereas wave nature and the momentum are directly related. So this is called de Broglie's wave equation. You may be asked questions on this. Next thing is uncertainty principle. See, according to the assumptions of classical mechanics, there is no limit to the number of dynamical variables which can be measured simultaneously and accurately. But according to Heisenberg's uncertainty principle, momentum and position of a moving microscopic body cannot be determined simultaneously and accurately. So when you are very accurate about the position, you are inaccurate about the momentum. When you are very accurate about the momentum, you are inaccurate about the position. So delta px, that is uncertainty about the momentum, delta x, uncertainty about the position. If you take the dot product, delta px dot delta x, you are getting h by 4 pi. This is actually closely equal to h by 4 pi. So this can be equated like this. See, E is equal to half mv square, which is the kinetic energy. If you multiply the numerator and the denominator by m, you will be getting m square v square by 2m. So mv is momentum p, so which is a p square by 2m. So if you take the differential, dE is equal to p square will become p by 2, sorry, p 2p. So that 2 and the 2 in the denominator will get cancelled. So p by m into dp. So delta E is mv by m into delta p, which means m will get cancelled, vx into delta px. So what is delta p vx? Delta x by delta t, change of a position with the time. So what you are getting is delta E dot delta t is equal to delta x dot delta px, which is closely equal to h by 4 pi. So energy and time cannot be determined simultaneously and accurately. Position and momentum cannot be determined simultaneously and accurately. These are all various statements of Heisenberg's uncertainty principle. Now, this is, we are getting into the mathematics of quantum mechanics. Watch closely. You have to Write down and understand. Otherwise, you cannot understand what I am teaching. First of all, you should understand what is a function. A function is a mathematical rule by which two numbers can be related. Suppose y is a function of x, then y is equal to x square, which means the relation between the number x and y is a square. So it is a mathematical rule by which two numbers can be related. If you take the types of functions, there are four types of functions. One is called algebraic function. You can see the example. An algebraic equation, f of x is equal to 2x cubed plus 4x plus 3. Second one is exponential function, f of x is equal to a into e power mx, something like that. Next one is logarithmic function, f of x is equal to a log kx. Another one is a trigonometric function, f of x is equal to a sin ax. So these are all various types of functions. Suppose your kinetics equation, the rate of the first order rate, it is a logarithmic function. So trigonometric function. So there are fundamentally four types of functions: algebraic function, exponential function, logarithmic function, and trigonometric functions. Now, there are two kinds of functions. There are functions which are called linearly dependent, which means that in a set of functions, if one function can be expressed as a linear combination of any other functions of the same set, then the functions are called linearly dependent functions. And for example, see f of 1 is 1, f2 is x, f3 is 7x plus 4 means the f3 can be represented as 7f2 plus 4f1. So one particular function of the set is written as a linear combination of other functions. You can introduce any coordinate here, any coefficient here, no problem. But you should not do any multiplication and all. It has to be a linear combination. You can sum up and you can multiply with a constant. That is what you can do. So this is called linearly dependent function. If you are not able to express any function of the set as a linear combination of the other functions of the set, then it is called linearly independent functions. So you should understand what is a linearly dependent function and what are linearly independent functions. And another important idea what we are going to discuss is inner product of the function. Inner product of a function over a given range of integrals is represented as, see, it is brace f of x slash g of x is equal to integral the limits. It is a range in which it has to be found out, the limits, and then f of x star g of x dx. Why this star? Star means it is the complex conjugate. Complex conjugate means you have to change the sign of the imaginary part. See, I have done some example works. Find the inner product of two functions. F of x is equal to ix and g of x is equal to x square over a range of integrals minus 1 comma 1. See, I'm going to find out the inner product. So integral minus 1 to 1 f of x star g of x dx. What is f of x star? You change the sign of the imaginary part. So it is minus ix into g of x is x square dx, and then minus I is taken out. Integral x into x square is x cube dx. So this becomes x power 4 by 4, and the upper limit and the lower limits are applied. So what is the upper limit applied? 1 by 4 minus the lower limit is applied. It is also plus 1 by 4. Sorry. Yeah, minus of minus. When you apply 1, it becomes 1 by 4. Minus when you become 1, it is again 1 by 4. So it becomes 0. So if you get the inner product of two functions 0, then these two functions are called orthogonal functions. They are called orthogonal functions. So now you do another example. Let us do f of x is equal to I sin x and g of x is equal to cos x over the range of integrals of pi by 2, pi by 4 and pi by 2. So integral pi by 4 to pi by 2. I'm changing the sign of the imaginary part because it is fx star minus I sin x cos x dx. So the minus I can be taken out. Integral pi by 4 to pi by 2 sin x cos x dx. So according to trigonometric equations, sine 2x is equal to 2 sin x cos x. So I can write sin x cos x is equal to sine 2x by 2. So it is equal to, so f of x g of x is equal to minus I is taken out, sine 2x by 2, and the 2 is also taken out. Sine 2x, when it is integrated, it is cos 2x by 2. So that 2 is also taken out, I minus I by 4. So it is cos pi by 2 into 2 pi minus cos pi by 2. So it is minus I by 4 minus 1 minus 0 is equal to I by 4. So as these two functions, their inner products are not equal to 0, they are they are not orthogonal to each other. Now you take down all these things. I will